everybody. Welcome to my class. Today I am going to discuss about what is called centripetal or centripetal acceleration and the centripetal force. So we are talking about centripetal, that means something like acting towards center. Therefore, we'll draw a circle here. So let's see what is called the centripetal acceleration actually. So instead of defining the centripetal acceleration, let's see that how to establish the relation between A V square, A equals V square by R. And also what you can say, V equal to, you know that, see V is R omega, so it is R omega square by R, that means it is R square omega square over R, and 1 power and 2 power is cancelled now, so this is R omega square. So we establish the relation between A, V and R, and also in terms of omega. So here this will be called the central acceleration or the centripetal acceleration, because when you see that an object is describing the circular motion about the center O, for example, okay, and due to the change of direction of this vector, there is change in velocity, although it travels with constant speed through around the circle with the change in angle as del theta, you can say. So in this case, it is found that the direction of this acceleration vector is directed towards the center. Okay, therefore this is called the centripetal acceleration. So while dealing with this sort of thing, we'll see that why is called the centripetal acceleration. Okay, by showing off the direction of A towards the center of this circular path. Let's see. So for example, consider a particle is describing a circular path about some center O. So at this point, for example, this is the radius. At this point, suppose the particles describe the velocity V, or you can call this as velocity vector V, because at this particular point the velocity has some particular direction, but every time around this circle the particle is changing its direction, and because of which there is acceleration produced in the object. So say in a small time delta t, the particle is at this position, okay, where you see the direction of the speed is, or the velocity is tangent to this point here, also this is tangent to the circle at this point. So this is V. Now what you can see in this case, the angle described is del theta. So in this case what you can see, at this point the velocity is V, and this point is also the velocity V, we call A and B, and we are taking the speed constant, okay, we are taking the speed constant. So instead of saying the velocity, it would be wise to say this at the speed, but at some particular point it has some particular direction. Therefore this V can be represented by the vector V, this is represented by the vector A. Now let's do some geometrical and we can call the experimental work to see this relation first. So at this point, if you just produce this line to see what is this angle. So you have to understand that what is that angle actually. So this angle is del theta, then by geometry you know that this is 90 degree and this is 90 degree. Why? Because tangent and this line, when they touch at the point, then tangent point, then this angle is found to be 90 degree by geometry. And also, because these two are 90 degree, this angle will be, what is the angle that is inscribed here, same angle you will find. You have to check geometrically. Every time you don't need to show here, but I will just remind you that how to check it, so that in the following sort of thing, I will tell you directly by geometry, so that you can find a way to see the things using your concept in geometry. So here I am doing in detail. So here at this point you can see, like, yes, this is 90 degree already, so this is also 90 degree and this is also 90 degree. Let's talk about this angle as x and here this angle as y. Alright? So in this quadrilateral now, OB, you can say it is x, alright? OB, XA. You can see del theta plus 90 degree plus another 90 degree, and then plus we have supposed this angle as x equals to how many? It is 360 degree, because in a quadrilateral the total sum of the angle is 360 degree. Now, so here in this case, what you can find here, del theta plus x equals to, transpose this 90 plus 90, so that is 180, 360 minus 180, so it's going to be now 180. And also, what you can see that x plus y is 180. So instead of this, what you can write here, x plus y. Okay, because this angle x and this angle y, if you say, they constitute a straight line, so that angle is 180 degree. Therefore, in place of 180 degree, we can write x plus y. And from either side, you get x and x that got cancelled out, so that you have y equals to del theta. So this angle we have supposed as y, and now we found the del theta, so that the angle between these two vectors are still the same. Okay, let us now consider, this is the vector and you see that this represents the sum of the vector. Okay, maybe here not given V2, so that it is also vector with magnitude, but in the vector sense what happens, this is something like dv. Alright, this is something like vector dv. So it can be by the triangular rule of vector, so you can find the direction over here. So just we are only taking the magnitude of this sum of the vector sum. Now, what you can see, like let's increase the vector length further by same amount v. Right? So this is the vector, and also here by the same amount v. What happened then? You have increased the magnitude of the vector by its previous value. That means we have just doubled the vector. Then what happens to this line? Then what happens to this line? Look at it. So the whole thing here is about this point to this point. You can see that we have just doubled. So this will be the midpoint. Okay, this is M1, this is M2. And because of this geometric situation, these two lines are parallel to each other. So by the geometric theorem, what we have said, whatever is the length of this, okay, this length will be double of the midpoint length, that is M1, M2. It's okay? And M1, M2 in fact it is dv. Alright? So this way we can see geometrically. So let's see that what happens next. So furthermore, what we see that, what we have seen actually that when the speed has been increased, that means it has been doubled, for example. In that case, what happens? The sum of this vector has also been doubled, that means dv has been also doubled. So let's see the rate and ratio change in this regard. So for example, say that your velocity is firstly v, and now, and what is the other factor? That is the time. Yes, other factor is delta t or dt. We can write here. So in general, I am talking, so you can write it. So there are the influencing factor are the velocity and time. Okay. And then what we have to see here, A equals, we have to find the ratio of dv and dt, because change of velocity by time is the acceleration. So what happens when the velocity was doubled? So when you are driving the car, in order to reach a particular distance, it takes some time. If you double the speed, then what happens? If you take only the half the time, that was what you can see actually, as the velocity has been doubled, the time has gone half. That is less by half second. Alright, this is a second. And now, in the same in that regard, if you see the what happened to acceleration in this case is dv means yes, and dv has been also increased by the same amount, double. When v was double, this distance was also double. So the change is happening in this ratio. Okay. So for example, it is double. So what we call actually dv is 2. So you suppose that this is 2x. And the time has been half, so that is in 1 by 2x. X cancel. In that case, what we found actually this is 2x1. But what is 2 in this case? 2 in this case is, in fact, this is v. So that means we have got it as v square. Now, what happens if you triple the time? For example, to triple the velocity. You have tripled the velocity. So in that case, what happens? This distance will also similarly goes like this. It is v another. So this will be now, okay, triple. So what is triple? dv will be triple. So when this is 3, this will also increase in the same ratio. But what happens? We have increased the time further, so it will take less time than before. Alright. So by how much? As it has been triple, that is the time will be 1 by 3. So let's talk about the acceleration. What is happening to the acceleration in this case? Acceleration in this case will be now, you can see it is dv by dt. So dv is, you can check here, it has been given triple. So dv is 3 times of x and dt is now 1 by 3 times of x. These two are cancelled. So what we have found here, this is 3 square, and in fact that 3 is here. In this case we can check here, this is v, so this is now just like v square. Okay, and what you call actually, and so on means what? So on means if you have something like that, like 4, 5, 6, it is n. And it is n, the time will be 1 by 3. In that case, a will be in fact nx by 1 by n x cancel out, so this is going to be n square. So again, this is now just like v square. It's okay. So therefore, what can you say? You can say that. Therefore, we can say that in this case, what we are talking actually a. That means dv a equals to dv by dt is proportional to what? V square. It's okay. So as we are just increasing the velocity, the changing velocity is also being increased. But at the same time, as you further keep on increasing the speed, the time taken to reach a particular destination will be reduced by that ratio. So therefore, in each and every case, what we have found that a and v square are proportional to each other. That means what we can say, one relation as a is proportional to v square. Let's call this equation 1. And let's further suppose we have another circle. at this point, what we are doing, like we increase the velocity previously. Yes, if you see here, we increase the velocity further and further and further and we form this relation. Now what we do, because we are dealing with V equals to A equals to V square by R, then we'll see that if we make a change in R, then what is going to happen for the acceleration. So in that case, let's draw a circle of appropriate length, circle like this, and now at this point it has velocity or speed, you can say V, or velocity vector as V, and then here it is another velocity vector, you can see V, but the speed is constant in this case. You can call this as dt times center. So you call this is center O, and this is position A, and this is position B. So in this case what happens, look, this is R. Now let's double the R or treble the R. So start from doubling the R. So in this case what I am doing, like, yes, I just increased the radius so that what I have here, it will be, my circle will be like this. It's okay? Maybe, okay, this gaps will be perfect. So this is the freehand drawing. These are not on a scale, but you should understand that I have just increased the radius R to the further R over here and further R over here. In this case, what happens? Like position B will be like this. Okay, this is B, and we can call this as B dash. And then here, yes, same velocity or not, we'll check. It is A dash. This is position A, so this is A dash. So you can further increase this sort of radius to form other circles also. That means at this point we are drawing the concentric circle. So what is happening in this case? So one new factor introduced is here, R, and another factor is V. Then we have what? dV. And also the time has some role. So we can write somewhere T, yes, dt. And then finally we have A equals to dV by dt. Okay, one factor. So look at here now. At this point, you can see in the white circle here, if you just take the angle between these two are, just earlier we saw that this is d theta again. So what happens here in this case? In this case, you will see that from here, yes. So these are making the same angle. Look at here, even the radius has been increased. This will make the same angle at the center. So what you can see in this case, if you just draw a line tangent to this angle is still now del theta. It's okay? And this is because they are following the same angle at this point, and velocity has been kept the same. That means what you can see here, this dV and this dV, they are the same in magnitude. That means while increasing the radius, there is no change in velocity, and because no change in velocity, because the final direction, change of direction remains the same, d. So this is why dV equals to dV and V equals to V in either cases. So here in this case, when you double the value of R, that means we have doubled the value of R. What happened in V? There are no change in V. That means no change in V. No change in V means there is no change in dV also, so remain the same as 1. And what happens over time? Let's suppose now, here in this case, from position A to B, for example, if it takes 1 second to reach from A to B, what happens? As the radius has been increased, then arc length has been also increased. Yes, by how much? At this point when the radius is double, this is also now, if this is S, it has become now 2 times of s. So definitely time taken at this point will be 2 seconds. So 2 times of 1 second. Alright? So what happened in that case? Like when the radius was increased, velocity remained the same, and also hence the dv also remains the same. But what happens? Time has been doubled. So it should have taken 1 second now because the radius is double. That means this arc length has also gone double. That means it is taking the double time. That means we have here, this is 2. Then what happens to A? A in this case. A in this case will be dv means you can take 1 and dt means you can take what? Dt is 2. It is 2. But this 2 is here r. So it looks like as if it is 1 by r. So okay. Another time what you do, for example, you can also further increase the length, maybe by any ratio, but in general what you call actually 3. R is now treble. This is another R. So R plus R, 3R, treble. In that case also if you draw the diagram like this, you will see whatever the radius, length of the radius, velocities or the change of velocity remain the same. But time taken sort of thing will be increased here by that ratio. Okay? So here in this case, let's see here now this time. So it is treble now. So what happens in that case? V remains the same and dv remains the same, but it is taking now 3 times of the time previous time before than this. So in that case, what we can say here, acceleration equal to we have now dv by dt. So let's see here. Acceleration as dv means what we have now in this case, dv remain the same, so that it is 1, and dt has been now tripled, so that it is now 3. So here you can see that 3 at the value of r, and so what did you find in this case? Now what is the relation between r and a? So every time you can see that a, changing a and r as 1 by r. So based on this information, what you can say, r is now proportional to 1 by r, or you can say that the inversely proportional to the radius of the circle described, the first circle described. So call this as equation 2. Now what you can do, combine. Okay, combining equations 1 and 2. What we have now, look at here, in equation 1 we have a equals to v square, and equation, as you combine equation 1 and 2, in equation 1 you can see we have got a equal to v square. So what you write here, a is proportional to v square, and also a is proportional to 1 by r, so we can combine them, v square by r. And this way we see that a is proportional to v square by r. So by the unit condition of the thing, you can also see that, okay, or you can just write down like this, a equals to k v square by r, and k is the constant of proportionality. You know, in general we write it. So for value of a equals to 1, v equals to 1, r equals to 1, what we have actually, k value, always 1, then k value will be 1. So therefore, in general, you can say a equals to v square by r, and now this is the established relation between a equals to v square by r. And also, if you would like to change that in the form of angular velocity omega, so you know that v equals to r omega, so square is square by r, and then finally that it is r square omega square by r. You cancel the like terms. So what we have now, another r omega square. So you can check the unit also, whether or not the unit is same. So a equals to v square by r, that means it is meter per per square second square per second square, and then it is unit of this is meter. So what you get here, meter square by second square times this is 1 by meter, cut. So what we have got here, meter per square second, and which is the unit for the acceleration.